Welcome to a new test and teardown video. This time it's another Hewlett-Packard. The HP 1120 500 megahertz probe. So this one is an active probe. So there's an amplifier both inside this box. But there's also an amplifier inside the probe itself. And look at the size of the probe. This one is only, I don't know, 12 millimeters or something like that. Quite thin and nice. Inside the probe, we got a field effect transistor. And we got 3 transistors. We got some resistors and capacitors and all those kind of things inside this one. Aren't you a little bit impressed? And I think what they're doing is they really want a super high impedance at the very tip. And so they're AC amplifying here at the tip. They're removing a DC component for that AC amplifier that is in here. And then in the cable, you got a coax cable and you got plus and minus supply. You got a DC restore, and I think there's another control signal as well. So it's 3 or 4 signals on top of the coax cable that is inside this nice probe lead here. Inside the box, it's powered by this standard kind of probe power. I think both Tektronix and HP, they're using exactly the same little 3-pin connector here. And as you see, we got 3 pins. So center is ground. And then the funny thing is, the one to the left here is 15 volt positive. And the one to the right is minus 12.6. And I think there's a reason for that, because 12.6 is a filament voltage standard. And then you can just drive a little amplifier tube, because this kind of power connector here, the standard was of course invented back in the tube days. So that is probably why it is like that. And what else can I say about this unit? You can turn on and off a DC restoring, and you can make it AC or DC, and then you can of course add a DC offset. So like this is the first stage of your oscilloscope, so of course you need to have DC restoring here as well, right? This one is nice and clean now. I got quite a few of these, and they were in the original foam boxes, and the foam boxes completely dissolved, and it turned itself into super duper nasty, sticky, corroding goop. And you can see some of the corrosion here. It's really hard to remove. Maybe I should show you some more of the different little parts that I got here, and it's all completely corroded and really bad. Yeah, we could go outside and have a look at my boxes so you can see how nasty that is. So now we are outside in my little stinker lab, and I can show you some of these probe boxes here, and they are absolutely terrible. So this material here, I really don't want to touch too much because it's super sticky and smelly, and as you can see, it goes completely to powder pieces here. And this, now I got this sticky slime on my fingers, and this kind of sticks to everything that has been inside this box. So here we got another one of these probes here, and this one is so bad. See? Yike. And here's another one as well. This is a little bit different type. This is a passive. No. This is also an active one. This is a different model, but the amplifier is in here. But anyway, see, sticky, nasty slime. I think I got one that is like almost identical. No, this is intact. But see, just touching this. But I think here I will be able to take the entire. See, I can't take it up. I can't clean this. Yeah, this I will be able to fix, right? And then there's a double-sided sticker here. But I want to clean all this. Maybe add some new. How about in the top? Can I? It's just really nasty. Yeah, you see, that was 1, 2, 3, 4, and that one, yeah, that's 5 probes. Yeah. So here's this little funny 3-pin connector. I've sticked in some mounting pieces here, and look at that. Here's the power consumption, only 1.3 and 0.6 watts, so it's not a lot. This is the negative supply and this is the positive supply. I've just connected like this, and what do you know, this thing works. Yeah, well, there is a little bit of loose connections. So right now it is happy. This is a 1 megahertz input here from my signal generator. I didn't end or load this correctly, so it's just free hanging like that. But anyway, this is just to prove my point how it should work. So I am in DC mode. So this switch here is DC, and then I am also in positive DC. So that means this knob here can do. Oh, let me show you on the scope. Probably better like that, right? So this is the DC offset, see? And the funny thing is that I can of course turn off DC offset, then it is in center, or I can go negative offset, and then again it's down here. But if I am in positive, I can't go below this. So this is how it works. Quite funny. This is 100 millivolt peak of input, and this is quite low input, but you can see a tiny little bit of noise, and that is of course the noise that is inside the amplifier. See, here we go, and it's probably also my setup with my wires and whatnot. And here is 1 megahertz again. Let's try and crank up to 10 megahertz. So it's about the same, right? Okay, I think I set the probe input on the scope for only 200 megahertz, but we can try and crank this up. So that was 10. Let's go to 100, 200. Yeah, okay. This is my probe. My input here is limited, so let's crank this. Nope. See here. Ah, yes. This is of course also because my this is not capable of handling hundreds of megahertz. I mean, what do you think? I should probably put a 50 ohm resistor, but this is 400. Yeah, so it's 100 anyway. But that explains probably why I don't see a very high frequency. But this is 100 at least, so it is still quite alright. So I think this unit is working. So when you're holding on the probe, it feels very warm. And of course it's capable of amplifying all the way to 500 megahertz. So you can imagine the front stage amplifier, that is a field effect transistor, that is driven really, really hard to make it amplify all that that fast, right? So it's 42 Celsius on this point where you would hold. Look at that. So that definitely feels quite warm. And if you look at my table right next to it here, it's 25. So that's also nice and warm, by the way. What about the unit? nothing. So it's all going there. So the first look inside, I still have this powered up, and it's been running for a little while. Oh, let me go and get the macro is here. I don't know if you can see that, but it's yeah, this transistor is 50 Celsius, and yeah, everything else is more or less ice cold. This is the front stage dual transistor, and that is the DC restore op amp. So let's look a little bit more in detail what is going on here. So this is the main unit, the inside goodies. The first thing you'll notice is this area here. Can you see this? This can't be good. So I think there's some sort of puke that went out of this capacitor. It's also a little funny thing here. So this I will definitely clean up. That is the DC restore op amp. And that is the input, the dual transistor for high impedance. And this coupling here is quite interesting, the way that they are feed forward to up the input, where they are DCing kind of back to it. So that means you will get intense high input DC impedance. So it's quite interesting, this circuit here. And of course they got reversed diodes here for input voltage protection, so you will be in between this area here. And this is a little Teflon feed through, because Teflon is very, very good for isolation, low leakage, compared to, yeah, the circuit board material, really, when it comes to really, really high impedances. This is a way to do it. Also, you'll see there's a coax cable and 3 single wires that goes to the probe cable, and that will be the output coax that goes to your scope. I wanted to show you the back side. If you look here, you'll see this little Teflon piece again. So this is the DC restore point, right? And then all this Teflon and fantastic things, right? And then you go to one of those really, really crappy switches. I mean, add a little bit of humidity to this type of material here, and you can see this is a type of material that can kind of soak up humidity, right? So this is a little bit ridiculous. Why would you do this if you didn't, yeah, use a proper Teflon switch, right? Oh yeah, since all the amplification and all this, yeah, AC gain comes directly from that probe, AC gains go straight through here. So they have a ground plane under this track, and this track is of course made to a 50 ohm width. So because this board is 1.6 millimeter thick, the width of this track is 2.7 millimeters. So this makes a 50 ohm transmission line, and then this is the AC output, and then there is of course a DC input from the DC restore op amp circuit. So yeah, that is what this unit is all about. I wanted to see if I could get all the way into the probe and show you what it's all about. So the way that you change the little pin here is you unscrew this and then you stick it in and then put in a new one from the inside, I think, right? And this one touches this little point here. And I don't know if this is possible to video, but this is a thick film amplifier circuit. Everything is inside a special kind of unit. You can't really get inside this one. So this is just where all the probe electronics is, really. I was hoping that I could get in here, but that is not possible. Otherwise I'm just gonna break it, and I didn't want to do that because this unit is actually working. So yeah, that is the trick with this thing. I don't think you should tighten this too much because this is touching. See, now it's a little bit loose, so then you tighten this to a point where the, see, still too loose. I think you should get down to, no, still too loose. Maybe there's supposed to be a little spring in here, right? And that is missing, because how is this touching? Yeah, this can't be right. Let me try and look at another one. So this one is another one. So this is quite lucky. I got a few of these. See, here the tip is nice and steady, and then, oh, there's a little thingy sticking out here, and that is probably a little bit springy. Yeah, yes, exactly. Here's the little springy thing. So this is definitely needed to get it working. And there was also some thermal grease or something like that in this one. And here's a HP product number for this little amplifier. Maybe there is a way to change this or take it out of its socket or something like that, but so far I'm not lucky figuring this out. I really don't want to break these because they're actually quite nice for measuring high frequencies at high impedance. You don't load whatever it is you're measuring on, so yeah, quite cool. So that is, yeah, what I wanted to show you guys. I don't know if you want to call this lucky or unlucky. I got another one that is called the HP 1121A. That is the one without the DC amplifier, the DC restore unit. So there's only a DC feed in filter with inductors and all that kind of stuff. And this one is not working. It's not using any kind of current, so there's of course nothing coming out of it. It's completely defect. I measured all the components here, so all this is pretty much all right. It is nicely inside a little aluminium housing and all that, and pretty nicely made mechanically. The probe tip here was completely wasted, and maybe it was dropped on the floor or whatever. So I finally figured out how to take this apart. I had to use quite a lot of violence, but of course it didn't work, so I had nothing to lose, and this is why I can make a little let's have a look kind of video on this amplifier. So the handle is made of aluminium, and then there's some rubber covering on it. Yeah, you can see I had to grip it quite good. So there's a thread here, and this thread grips into this piece here, and they added some glue in here. So these two pieces, they were locked together like impossible to get out. And then we got a little oops, this little lock washer goes into this groove. So when this one is on like that, I unscrew this, remove the little lock washer, and then pull this out. And now you can see this is a single piece metal with, I don't know how they milled those screws for all the wires and such. That is a little bit amazing. And you can see the coax cable in the middle of the, it goes in here obviously, and then all the DC cables, they go out here and goes into the grooves, and then they are soldered to the little tiny little module. And this module consists of a very special field effect transistor and 3 normal transistors and some resistors and whatnot on a thick film circuit. And it is of course made for good cooling, as you can see here. And there's a piece of glass isolation under it. Really, really neat. Yeah, so we can't get any further in without breaking it, but yeah, what the heck, it doesn't really work anyway. It could be interesting to take a few photos. Let me see if I can probably add a few photos. I kind of did not expect that to happen. It was quite easy to crack off the lid. And it's on glass. And you can even see through. That is one amazing chip. So there's a fill defect transistor at the beginning. And then 3 smaller. I'll try and get a super macro for that. Like that, huh? Now we are in macro video mode here. Oi, 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 let me see if I can get it into focus. This is ultra difficult to video. But you're probably gonna enjoy this a lot. So the substrate is with all sorts of resistors as well on the glass. And then the gold and the VS like that. Wow, that is one amazing module, I must say. I am quite impressed. After I have been posting some pictures, some of the really nice and sharpest high resolution pictures I took of this chip, I posted them in a local Facebook group that is called I Take Pictures of Electronic Parts. And after only 2 days, I got 394 likes and 47 comments. So that is absolutely amazing. We got comments on the substrate and possible faults may be found and all those kinds of things. And if I scroll a little bit down in the line of comments, we find a guy called Duffy that traced down all the different components, and so he added all the numbers, designators for all the different components from the schematic on this really nice picture, so that we can see how everything here is done. He also found a missing capacitor in the original schematic that seems to be in the product. So thank you very much, and I'm also happy that you sent me the picture in nice high resolution, so I could add it to this video. And with that, I will finally conclude this video.
Remember, please like and subscribe.